if a sound signal is there, different types of sound signal will come. We'll see that one, how it will be. If a sound signal comes like this is the noise, the disturbance, what we say. Are you getting this one? So what is the disturbance? Anything, whatever you make noise, no, that will become. So that this, can you hear this for longer? I think anybody will purchase music system to hear noise, not needed, no. So in a class, if some 10, 15, 20 students, if they speak continuously, then what happen? We do get a noise. It will be highly irritating, disturbance, or what you can call noise, will be of like this. Then next, again, a signal of this one. Next one. What is this signal? The signal is of constant intensity. So this will be a noise. So it'll be highly irritating. You can't hear it. So immediately what happens, will close our ears. Then what about this? This is off like this. What is the intensity? All the time constant, loudness constant. Now instead of this, if I bring a signal which is of this kind, no, not only this, so something of like this. So what's happening intensity? I'll start from here. La 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 la. You see what's happening now? Let's a bit some melody got added up, no? If the intensity varies, so this will be melodious. You can put it. This is constant loudness. It's of no use, no? This is a noise. Better say like there's a noise signal. Constant loudness signal. This is a melodious signal. So therefore, if I play musical instrument, tell me like how that musical instrument should be of this kind. If I sing a song, the intensity should vary. So how you control that variation of intensity, that will add to melodious. Got the idea, no? So now this will take one cycle, no? This will become one cycle. So what is the beat frequency? So the time taken for the intensity variation to complete one cycle. This is what we are interested. How to calculate beat frequency? This is a method. So we do, what is use of this? I think you can see the drums and plates, musical concert. If you go for any musical concert, that one. So the particular person, what happened, he'll have having so many plates, no, some 5, 6 plates of different thickness and also drum there. Why so many plates? One plate is enough, no? If you strike only one plate, you may get sound signal of like this. If you have several plates, the different plates will have different thickness. So different plates, what happen, will produce sound signal of different frequency. Then if a 5, 6 different sound signals, what happen, different sound signal frequencies, if they undergo superposition, what do we get? We get a intensity which is going to vary with the time. Then a melody will get added up. In the guitar, why 5 wires? One wire is enough, no? The different wires, what happen, they will produce different sound signals, different frequency sound signal. So when I strike it continuously different wires, that each wire will act like a source. So 5 sources are there of different frequency. When the waves come off due to that 5 sound source of different frequency undergo superposition, what do we get? We get a intensity varying with the time. Then melodious signal will come. So that's why if you look at the music anywhere, any like some function is there, no, where person singing song, why we have a tabla, flute, piano, guitar, why so many musicians are there? One, so the different, so what happen, each musician, what happen, will produce some 5 or 6 different sound signals. Like that, some 5, 6 instruments are there, some 15, 20 different sound signals of different frequency. They undergo superposition. The intensity will vary in one specific way and it will become more melodious. That's the purpose of why so many instruments, and in a given instrument, why so many wires will be there, or in the tabla, what happen, why you will strike at different points. Piano, why you will strike the different buttons. Different buttons striking what pen will produce different sound signals of different frequency. So each particular button will act like a source of sound of different frequencies. So that will help us to generate a beats. So therefore, so what is all purpose of the music? I should generate the beats. That's all over. I should generate beats. If beats are there, the signal will be melodious. That's why we are discussing. Anybody having doubt, you can clarify. Anybody having doubts, you can clarify. Okay, now how to calculate the beat frequency, or how many beats are heard per second? Anybody answers? So what is the thing overall? The first thing is directly the difference between these two signal frequencies, or how many beats are heard per second. F1 minus F2, problem solved. Or else what you should do, time interval between two successive maximas. You look at this one. What is the beat period? 1 by 2 by 0. What is the beat period? 0.5 seconds. Time interval between two successive maximas, or time interval between two successive minimas, or in intensity versus time graph, calculate the one in time period, one beat period, time taken for the intensity variation to complete one cycle, or in amplitude versus time graph, find out the distance between positive and negative peak. That will be the beat period. The reciprocal of this beat period will be the beat frequency. Tell me among all which is easier. Anybody wants to reply? I'll give two sources. Let me directly get into the problem. There are two sources of sound. F1 equal to 4 Hz. F2 is equal to no. Tell me like how many beats I'm going to hear. What is the beat frequency? The beat frequency is very simple. What you should do? F1 minus F2. The difference 5 minus 2. Yes, there's a beat frequency. What do you mean by beat frequency? 3 Hz means what does it mean? So you calculate the beat period. What is the beat period? 1 by, I think let me take some value of this kind, calculations. So therefore it should be reciprocal of beat 1 by 4. 1 by 4 means 0.25 seconds. Anybody answers? What do you mean by that? In 1 second, one intensity variation will get completed. How much it is? 0.25 seconds. So there's a time taken by intensity cycle to complete intensity variation to complete 1 cycle. So in 1 second, how many cycles will get over? 4 cycles will get over. So how many beats I'm going to hear? 4 beats I'm going to hear. What is 1 beat? One intensity cycle is called as 1 beat. Got the idea, no? Now tell me, like, if I give you a problem, find the number of beats. What you do? Will you directly take F1 minus F2, or what you do? Will you come for mathematics like this? Then you'll find out the time interval between two successive maximas, time interval between two successive minima, or you plot intensity as a time graph, calculate the beat period, reciprocal of beat frequency, the number of beats heard per second, or amplitude of time graph. Among all, tell me which is easier. This is easier, no? Just take the difference between them. That is enough. Okay, got the idea, no? So how to calculate the beat frequency means just take the difference in signal frequency. That is enough. This is a mathematics. I shown it in numerical solvent. We're taking this one here. We have to take a difference. Okay, I get this. So let's go for a tuning fork. We'll discuss some problems with the tuning fork. Now, you know